Hello and welcome to our learning activity. This is your teacher Marichu and we are now on Math Box Senior High School General Mathematics for Quarter 1, Week 4C. The objective: the learner represents an inverse function through its A. Table of values and B. Through the inverse function's graph. Let's get started! We will start with the generalizations. And let me read. The inverse of a one-to-one function can be represented through its table of values in graph. The domain of the function is the range of its inverse, and the range of the function is the domain of its inverse. The graph of the inverse of the function is its reflection along the line x equals y. Example 1 is here. Let me walk you through with it. Just go over this example. By the way, these are the table of values for the inverse function given and its graph. As you can see, we have the blue line, it's the graph of the original function. And we have the green line, it is the inverse of the original function. And this broken red line is actually the line y equals x or x equals y, either way. As you can see, this original function can be reflected on this side through the line y equals x. So that is, this is the original function, and the green line the green line is its inverse function graph. Moving on, let's get started with exercise number 1, and we have 5 numbers to solve. It says, represent the following inverse functions through their values, table of values and their graph. For number 1, we have f inverse of x equals x plus 3. So for the solution, let me read this out. This is the function x plus 3 and this is the inverse of f of x. So we want to have certain values for x. X is an independent variable, so we can assign any value arbitrarily. So in this case, I just follow the example. So I have given you the 5 values for x. X equals 0, 1, 2, 3, and 4. Now, let's get started with f inverse of 0. So we have to substitute x equals 0. So that's 0 plus 3, that's 3. F inverse of 1, that is 1 plus 3 is 4. F inverse of 2 is 2 plus 3 equals 5, and so on up to f inverse of 4 is equal to 4 plus 3 is 7. So this is now the table of values for f inverse of x equals x plus 3. And this represents the green line in the graph. So, okay, let me show you the graph. The green line. So this is the green line, our f inverse of x equals x plus 3. Let's try to see if x is 0. So we have here x is 0 here. Then we have the value is of y is 3. Or f inverse of 0 is 3. So we have a point 0, 3. And then we have a point also 1, 4. Then we have 2, 5. Then we have 3, 6. Then point 4, 7. And we can form a line here. It's a linear function. Then this is the red line. The broken red line is actually the reflection line. And how to graph this blue line? Okay, let me show you that just for the reference. Since we have the table of values given our f inverse or the inverse function, in the previous video, we have a topic on how to get the inverse of a function. Then once we get the inverse of a function, we can always go back to the original function by, again, evaluating or manipulating the inverse function in such a way that we're going to get its inverse. Of course, the inverse of the inverse function is the original function f of x. In this case, it says in one of the video, just follow the link or just click the link below. I will just write here in the description of this video the link for you to review. No. So it's in learning activity sheet 4B or 4A. Okay, so we have here another table. We have x and f of x. We are actually recovering what is that f of x. We may not know the original function, but based on the table of values, we know. We know that. Remember that the domain or the range, the x values of the original function is actually the range of the inverse function. And the range of the original function is actually the domain. The range of the original function, yes. It's actually the domain of the inverse function. So we just have to interchange like this. In this function, f inverse of x, we have 0.03. And in the original function, we have 3, 0. Then we have 1, 4, and 4, 1, 2, 5, 5, 2, and so on, up to 4, 7, 7, 4. And it says here, this represents f of x and the blue line. So we have a 0.30. Let's try to go over this function. So this is 3, 0. This point is 4, 1. This point is 5, 2. This point is 6, 3. This point is 7, 4. But in the inverse function f of x, say, let's try to concentrate on this 7, 4. It has to be that there's a counterpart point on the inverse function 4, 7. Let's see. This is the green line, and we have 4, 7 is here. So this point or coordinates, the inverse of this is actually 7, 4, this one. So if we flip over this line, the red colored line, if we flip this graphing paper, you will see that these two lines, the green line and the blue line, coincides each other. That is the concept of inverse function. So this is for number 1. We will proceed with number 2. We have f inverse of x equals x minus 5. Solution. This is similar to the previous example exercise that we had. So let me show you the graph. Okay. So let's try to go over this. F inverse of x equals x minus 5. So I assign values for x as 0, 1 to 4. So as you can see here, then substitute it to the function or the inverse function. So this is negative 5. 0 minus 5, this is 1 minus 5, and so on. So these are the values. And the graph is the green line. Okay, we have to go over the graph later. Now, how to get this x and f of x values? So just interchange. This is the domain of the inverse function. And this becomes the range of the original function. And this is the range of the inverse function. This becomes the domain of the original function. So having done this, the graph of this function is the blue line reflected here in our graph. So we have again the red line here, the broken red line, it's y equals x, the reflection line. Then the green one here is f inverse of x equals x minus 5 as given. And of course, we have its original function, f of x. Okay, so we have it here. So you can just pause this video and try to go over this. Moving on to exercise number 3. F inverse of x equals 4x. So for number 3, again, the same values for x we had assigned 0, 1, 2, 3, 4. Then, substituting to the f inverse function, 4 times 0, 0, 4 times 1, and so on up to 4 times 4 equals 16. Anyway, if it's a linear function, any 2 points, we can already graph the function. But for the sake of discussion in this learning activity, I make 5 points. But as I said, 2 points will do. A linear function or a line or 2 points determines a line. So if you have 2 points, you can create a line. So anyhow, this one, again, this is the table of values for f inverse of x equals 4x. And this is the table of values for f of x, which we may not know. Of course, in the previous video that I had presented, there is the process on how to get the inverse function. So having this as the inverse function, if you take the inverse of this function, you will end up with the original function, because the inverse of the inverse function is the original function. So in this case, we don't need to know. By just having, you just try to take a look at this table of values for x and f inverse of x. We're done with this. And then we need, say I need to graph or to reflect on the graph the original function, but I don't need to know the original function, but just the points on that original function. So what are those? So remember that if two functions are inverses of each other, then the domain becomes the range of the other, and the range of the first function becomes the domain of the other, or its inverse function. So that's easy. That's how it works. It's so easy to understand. Let me focus the graph. In this case, we have a very nice graph. So this is a steep function, y equals f inverse of x. This one, it's actually given to be 4x. And this is its inverse, the original function, the blue line. So it says here y equals f of x. And of course, the red line, the broken line, y equals x equals the reflection line. So this is for the graph of number 3, inverse function. So you may pause this video and go over it. You may copy that and submit it to your teacher. It's one of your formative assessment. Number 4, f inverse of x equals 8x minus 1. Solution. We have the same table of values, 0, 1, 2, 3, 4 for x. Then substitute it in the given function that we have these values. Let's see, 8 times 0, that's 0 minus 1 is negative 1, and so on. Then 8 times 4, 32 minus 1, that's 31. So all values, negative 1, 7, 15, 22, 31 are reflected here, and the given value for x, arbitrarily chosen. Okay, so the graph is the green line. And of course, interchanging this row, x and f inverse of x, we have x here becomes the values of f inverse of x, negative 1, 7, 15, and so on. Then f of x are the values of x in the inverse function. So the graph of this original function that is represented by the blue line. Showing you the graph of this function, we have here the green line represents the inverse function, that's the given, and in this case, it's actually 8x minus 1, okay? And in this particular exercise, we don't need to know what is that y equals f of x, but we have graphed it based on the table of values found in the given function. So this concludes number 4. We are now to move on number 5, 2x plus 5. That is the inverse function of x. For the solution, f inverse of x equals 2x plus 5. So we have here x equals 0, 1 to 4. Then substituting those values of x to the given function. Here f inverse of 0, 2 times 0 plus 5, that's 5, and so on. Okay, you can pause the video and go over with these values, or the process of this, how to come up with 5, 7, 9, 11, 30. It's so easy. Then the graph is the green line of the inverse function, and the graph of the original function is the blue line. Interchanging the x row and the f inverse of rho and renaming it as x and f of x, we have it here. So for the graph, okay, the graph is, we have the blue line is actually the original function. Then the green line, this is the given function's graph. Okay, and we have the reflection line y equals x. Okay, this concludes our solution for exercise number 1. Moving on to example 2. Now we're done with discussing the table of values and the graph of the linear functions and its inverses. And we are now on example 2. Example 2 deals with inverse functions in the form of rational functions. Here, example 2, it says represent f inverse of x, which is equal to 1 over 1 minus 2x through its table of values and its graph. So for the solution of this particular example, walking you through this one. Okay. So in this case, rational function involves already asymptotes. I had also discussed how to get vertical and horizontal asymptotes in the previous video. So I will just send you the link in the description below for this video so that you can backtrack with, just in case you miss the process on how to get the asymptotes, the vertical and the horizontal asymptotes. This is the conclusion of example 2. And moving on to exercise number 2. So we have 5 numbers to discuss. And let me read the direction. Represent the following inverse functions through their table of values and their graph. Show your solutions in your activity notebook or your answer sheet. So we have 5 numbers to discuss. And in this video, I discussed this. Let's start with number 1. F inverse of x equals x minus 2 all over x plus 7. For the solution, by inspection, okay, since we have numerator and denominator, it has to be that this f inverse function is to be defined. But take a look at x plus 7 as the numerator. So if x is negative 7, that is negative 7 plus 7, that makes it 0. And at that point, the function is undefined. So we have a vertical asymptote at x equals negative 7. Take note, if it is a rational function, we may have vertical asymptotes and horizontal asymptote. Now take note, let's also get the vertical asymptote, the horizontal asymptote. We are done with getting the vertical asymptote. Those are the aspects of graphing and the table of values that we need to know so that it will be easy for us to detect the behavior of the graph by just simply giving the points, or assigning the x values. Remember, there are a lot of real numbers, infinite of them, that we can substitute to this given function. But if we know the technique, we can manage to limit the number and say three numbers or 3 values for x. You can already know the shape of the curve of this rational function. So we're done with getting the vertical asymptote. How to get the horizontal asymptote? Again, I will just list, or you can just click on the link below this video on the description side on how to get the horizontal asymptote. But let me illustrate it here. So we need to understand the degree of the numerator and the denominator. What are the degrees? So in this case, we have a linear function in the numerator x, it's x minus 2, and another linear expression in the denominator. So if it is linear, then the degree is just 1. Meaning, what's the power of x here? The highest degree of x. In this case, let's call m the degree of the numerator. I mean n, as in November. The degree of the numerator. So n here is 1. And the degree of the denominator, m. M here, the power of x also is 1. So we have n equals m, or simply 1 equals 1. So we have a property that if the degree of the denominator and the numerator are equal, then the function has a horizontal asymptote y equals ab. Now what is a and b? A is the leading coefficient of the numerator, meaning the coefficient, the numerical coefficient of the term with the highest degree. In this case, we have here x and we have here 1x. So your a is 1. And in this case here, in the denominator, the first term is, the leading term here is x, and the numerical coefficient for x is also 1. So a over b, that's 1 over 1. So we have y equals a over b equals 1 over 1 equals 1. So the horizontal asymptote is y equals 1. Now, the tip to get 3 points at the left of x equals negative 7 and another 3 points at the right of x equals negative 7. Why negative 7? Because negative 7 is x equals negative 7 is where the vertical asymptote lies. So that what makes this function, rational function, undefined. So we have to get 3 points on the left and on the right. So we have here, I have chosen negative 8, negative 9, and negative 10. That's 3 points to the left of x equals negative 7. And to the right of negative 7, we have negative 6, negative 5, and negative 4. So we have this. And we have to substitute these values of x in the original given inverse function, x minus 2 over x plus 7. So just walk through, you can pause the video and just go over this. So in this case, we have if x is negative 10, we have 4. Then negative 9, we have 5.5, negative 8, we have 10, and so on up to negative 4 for x, we have negative 2 for f inverse of x as the values. Now we have the graph. Okay, in this graph, I only included here the graph of f inverse of x because that is what is asked for us to do. That we're going to give the table of values and then graph the given function. In this case, these two graphs are the graphs of the given function. We have to reflect the vertical asymptote x equals negative 7. The blue broken line represents the vertical asymptote. Meaning, the graph of the function will just get closer and closer. As you can see on this side here, gets closer and closer, but it will never touch this blue broken line. On the right part of the graph, we have it here. It will get closer and closer as it gets to negative 7, x equals negative 7. From the right, the function is decreasing without bound. That's the proper term. Okay. And of course, we have also y equals 1. And this is our horizontal asymptote. Just take a look at this. As we give values for x, as x increases without bound, to infinity, to positive infinity, then the values for y gets closer and closer and closer to y equals 1, but it will never touch the horizontal asymptote. Okay? In the same way here, in this part of the graph, as we choose values for x to be, say, -10, so we have here the counterpart of -10, that's 4. Then if we choose -11 here, it gets closer and closer and closer to y equals 1. But take note that we have here a horizontal asymptote, so it will never cross, it will never touch the y equals 1 as our horizontal asymptote. On this part of the graph, if we make our x value equal or small or infinitesimally small, and it is closer to -7, we just have a value for y that is increasing without bound there. But take note that it will never touch this vertical asymptote. Moving on to number 2, f inverse of x equals 3x plus 1 all over 4x. Solution. It says here, by simply looking at the function x equals 0 makes the function 3x plus 1 all over 4x undefined. So we have a vertical asymptote at x equals 0. The degree of the numerator n equals 1, and the degree of the denominator m equals 1. In this case, the degree of the numerator equals the degree of the denominator, then equals 1. The horizontal asymptote is y equals a over b. Going back to the given function, we have a here is the coefficient of the numerator, the leading coefficient, so it's 3. And then the leading coefficient of the denominator is 4. So y is equal to 3/4 is the horizontal asymptote of the given inverse function. Okay, so we have again the tip, how to get the points so that we can have the behavior of the curve that we're going to graph. So we have, tip is to get 3 points at the left of the vertical asymptote x equals 0 and another 3 points at the right of x equals 0. So fixing our point at x equals 0, so 3 points or 3 whole numbers to the right, that's 1, 2, 3. And then to the left of 0, we have to pick 3 integers. Closer to 0, we have -1, -2, and -3. Those are our critical x values that will give us the most likely behavior of the curve that we're going to sketch the graph. Then, substituting these values, we have the table of values here as the result. So for -3, we have 2/3, we have it here, -2, 5/8, -1, 1/2, or 0.5. Then for x equals 1, we have 1. For f inverse of x, for x equals 2, we have 7/8. And for x equals 3, we have 5/6. Plotting this coordinates of points in the graph, may I remind you that in graphing, you have to see to it that the grids are equally spaced. In this case, okay, let me show you the table of values so that we can plot in the graph. So in this case, we have to plot in the asymptotes. The red broken line here, as you can see, is our asymptote, horizontal asymptote, y equals 3/4. So I made that our grids, the distance is 0.5 so that it would become closer. So I zoom in the graph, so to speak. Then this is x equals 0. The y-axis actually serves as the vertical asymptote. So these two lines, the vertical asymptotes and the horizontal asymptotes, take note that the graph of our rational function must never touch these asymptotes. And as you can see in the graph, it never touches. This part never touches this part and the vertical asymptote, and also this part. Okay, so moving on, this is the given inverse function. So I name it y equals 3x plus 1 all over 4x. Now let's plug in the values. Let's try to verify for the sake of discussion. Negative 3 for x, so we have 2/3. So negative 3 is here, and 2/3 is, this is 0.5, so it's 0.6666 and it's 0.67, so we have it here. Then for negative 2, we have 5/8, negative 2, 5/8, somewhere here. Then we have negative 1, that's 0.5, so we have it here. And also for 1, x equals 1, we have 1. So we have here on this side. Then x equals 2, we have 7/8. It's higher than 0.5. And we have x equals 3, it's 5/6. It's below 1. But it's higher than 0.75. So here's the behavior of the graph. So this is for number 4. Number 2. Moving on to number 3. We have f inverse of x equals 6 over 5x minus 1. For the solution, by direct inspection of the rational function, we can say that x equals 1/5 or 0.2 makes the f inverse of x equals 6 over 5x minus 1 undefined. So we have a vertical asymptote at that particular value of x. The degree of the numerator is n equals 0 here. It's a constant, so n is 0. And the degree of the denominator m equals 1. So in this case, we have the degree of the numerator is less than the degree of the denominator. So the horizontal asymptote is equal to 0. So we have the line y equals 0, or this is the x-axis. So meaning the x-axis is our horizontal asymptote. Now what are the 3 points to the left and to the right that we're going to get? Now since x equals 1.5 is the vertical asymptote, or x 1/5 is equal to 0.2, 0.02. So meaning we can get values to the left of 0.2. These values are 0, negative 1, and negative 2. And to the right, obviously, 1, 2, and 3. Substituting those x values in the given function, we have the table. If x is negative 2, then we have negative 6/11. Negative 1, we have negative 1. 0, negative 6. We have 1, it's 1.5. We have 2, it's 2/3. And we have x equals 3, we have 3/7. Moving on with the graph and the table of values. So plotting, we can see that the x-axis here is actually the horizontal asymptote. And we have the broken blue line. It's actually the vertical asymptote, x equals 0.2. Then, plotting in the points that we had in this table will make this graph. So you can pause the video and try to scrutinize these parts of the graph or go over the graph so that you can also draw this graph in your answer sheet and submit it to your teacher as part of your formative assessment. For number 4, f inverse of x equals x plus 8 all over 5. Though this function is or does have a denominator, but it's a constant. So this is, we consider this as a linear function with a constant. Okay, so this is just a constant, so we can say actually as 1/5 x plus 8/5, so it's linear. Let's take a look at the solution. Direct inspection of the rational function. Then it is, as I said earlier, it's a linear function since the denominator is a constant. So we just need 2 points to graph a linear function. Any 2 points we can assign. But in this case, let's have the most convenient value for x is 0. And in this case, 0 plus 8/5, that's 8/5, or simply 1.6. And another one, I'll just get the 0 of this function, meaning what is the value, that value of x that will make the numerator 0. So we have -8. So f inverse of -8 is 0. So we have 2 points here, 0, 1.6, and -8, 0. And of course, if we interchange the domain and the range, this becomes the table of values for our original function, as what we had done in exercise number 1. Okay. So in this graph, I reflected also the original function aside from the given function, f inverse of x. This is the green line, reflects the given function, and the blue line is actually the original function. In here, I just wrote y equals f of x because I wasn't able to get the inverse of this function, but for sure it's still a linear function. But where did I get this blue colored line in plotting? Remember earlier that this table of values, we just interchange the domain and the range to get the value of this. Okay, so this concludes our solution for number 4. Moving on to the last exercise, number 5, f inverse of x equals 2x plus 5 all over 3x. Again, we have the rational function. So for the solution, we have, by direct inspection again of the rational function, x equals 0 will make the denominator 0, or the whole function undefined. So we have a vertical asymptote at x equals 0. Then the degree of the numerator n is 1 and m is 1 also, so n equals m. The horizontal asymptote lies in a over b, and this is our a, 2, and this is our b, 3. So y equals 2/3 is the horizontal asymptote. Since we have a vertical asymptote at x equals 0, then we get 3 values to the left of 0 and 3 values to the right of 0 to have the table of values. So substituting this table of values for x, in this case we have -3, -2, -1, then 1, 2, 3. So we have to plug in the values. Let's try to see. F inverse of -3, that's 2 times -3 plus 5 all over 3 times -3. So it's 1, 9. Then -2, -1, 6, -1, -1, 1, 7/3. Then we have 2, 1.5. If x is 3, we have 11/9. So for the graph, we have it here. So again, we have to plot in the horizontal asymptote, which is y equals 2/3. And the vertical asymptote, x equals 0, is here already. So this is now the behavior of the graph. F inverse of x equals 2x plus 5 all over 3x. This concludes our solutions for exercises numbers 1 and 2 in this particular learning activity. So for the numeracy scale, you can key in the link in your gadgets for you to explore more examples on this topic on graphing inverse functions and the table of values of such, or you may click the link below the description. So this concludes our discussion in this learning activity, and this is Teacher Marichu saying always stay happy, healthy, and safe. Thank you and God bless.